Alright guys, welcome to 8.7, the law of cosines. Teaching this one outside, so enjoy the birds in the background. Here we go. Okay, so the law of cosines, I'm just going to start this lesson out by just giving you what the law of cosines is. If you want further proof as to why this works, I'm happy to provide that for you, but I'm not going to do it as part of the main lesson here. So I'll post a video on Classroom that will also lay that out for you if you're interested. But here is the law of cosines. Now I want to remind you of a couple things. First of all, when you are looking at all of this, you see a bunch of A's, B's, and C's. The first thing I want to highlight here is the fact that this whole thing, all three of these are essentially the exact same formula. They're just switching around the A's, B's, and C's. So I'm really only going to focus on the first one here. And on the first one, notice how it starts. A squared equals B squared plus C squared. That should look somewhat familiar. You're probably more familiar with the third version of this, where A squared plus B squared equals C squared. Yes, that is just the Pythagorean theorem. So we've studied that in depth. So that's how all of these start. Okay. And then I want to point out another thing before we get into what this actually all means, and that is, remember that your lowercase, and you might want to make a note of this, your lowercase letters that are here in the law of cosines stand for side lengths. Okay, so lowercase letters stands for the side lengths. Okay, that is important to note. The uppercase letters stands for angles. Okay, so take mental note of that, or make that in your notes clear. So in other words, when you're taking the cosine of something, you're looking at the angle. All this other A, B, and C stuff, that's just side lengths in the triangle. All right, so just to point that out here, this hopefully should be in your notes, but highlight that and make sure you are good. When would you use the law of cosine? So I gotta start by telling you again that we are not working with right triangles. If you're working with a right triangle, you're going to just use straight trig, you know, the SOHCAHTOA that you learned a couple lessons ago. Okay, and then I would always attempt to use the law of sines. So if you can use the law of sines, use the law of sines. But if you cannot use the law of sines, that's when you would attempt to use the law of cosine. So again, the thought is, first, can I use trig? Okay, is it a right triangle? If the answer is no, go on to law of sines. If I can't use the law of sines, then I'm going to try the law of cosines to solve triangles. Okay, so essentially, whenever you can't use the law of sines on a non-right triangle, that's when you're going to attempt to use this. So here we go. The steps to doing this, you're going to want to draw it out if it's not drawn for you. Okay, so on 3.8, there's one drawn for you. And the biggest hint with this is to always start with the side opposite of the angle that you know. Okay, so we know one angle here. We're going to start with that. Okay, and I'll make some sense of this equation here. Okay, so law of cosines, if you'll notice, there's a little bit of a pattern to it. So I'm going to scroll back up here so you can see the pattern. Notice in the pattern, and I'm going to just erase some of this stuff here so I can highlight this again. The pattern here is this. However it starts, it ends. Okay? So, and remember that the uppercase letters are simply angles. Okay? So if you know an angle, that is where you're going to start this whole process. All right? So let's go back to this here now. We know an angle. All right, and so we're going to start with the side length opposite of that thing. All right, that is, in this case, that would be called g, lowercase g, but they're denoting it with an x. Okay, so I guess we can use x. So essentially we have x squared equaling to, again, that's the side length that's across from the known angle, equaling to the other two side lengths squared. Okay, so I'm going to say 15 squared plus 19 squared, and then you will always subtract 2 times those two same pieces. So 2 times 15 times 19, And then you're going to multiply that also by the cosine of the known angle, which is 125 degrees. One thing to note here is that this whole thing here, that's just one piece. So when you're doing this out, you're going to want to write that as one number when you do that. So a lot of times I'll start this whole problem with that. So if you take I would actually start with the cosine of 125. So if you're in degrees in your calculator and you hit 125 and then hit the cosine, you're going to get a negative value. You'll figure out why that is the case when you take pre-calculus. I'm not going to go into it here. But then we're going to multiply that by 19, and then we're going to multiply that by 15, and then we're going to multiply that by 2. And when you do that, you should be getting a negative 326 we'll just call it 0.9. Okay? And that's negative. So that whole thing simplifies to that. If you take 15 and you square it, you should get 225. When you take 19 and square it, you should be getting 361. So I encourage you to try those. When you add those together, you end up with 586. So here we go. We have 586. Let me just fill this all in. 586, and then we're subtracting a negative, so we're actually adding 326.9 and setting that to equal x squared. Okay, so when I add those together, I get 912.9. When I take the square root of that, x is going to equal 30.2. Okay, so the answer to x here is 30.2, and I solved that using my law of cosines. Now, if they ask you to solve the rest of the triangle, what's cool about this is once you have an angle side length pair, you can actually use now the law of sines to solve the rest of this, right? So I could say the sine of 125 over 30.2 is equal to the sine of d, for instance, over 19. Okay, and you can cross multiply and solve for d, and then you can do the same thing for f. All right, and as you'll see here in a second, you could also use the law of cosines again if you wanted to, if you didn't want that little bit of rounding error that's going to come from this rounded version of things. Okay, so that's 3a. Hopefully that made sense to you. Let's look at 3b. So for 3b, it looks like I already gave you the equation here. They drew it out for you. So on 3b, notice we have an angle that we know, so we're going to start with the thing opposite of that, which is the x. So we have x squared equals 7 squared plus 4 squared minus 2 times those two things, multiplied the cosine of the angle that you know. All right, that is the law of cosines. And so when we do this out here, and then maybe what I'll do is, once you pause the video and go ahead and, we'll pause the video here and see if you can get this answer on your own. But now that you've come back, let's go ahead and do this out. So we have 7 squared, we have x squared is equal to 7 squared, which is 49, plus 4 squared, which is 16, minus, and then we're going to do this whole thing at once. Again, so that's going to be 62. I always start on, if I'm using the iPhone, which I don't encourage you to do, use your calculators and know how they work, but if you take the cosine of 62 degrees, you'd hit 62 and then cosine on the iPhone, but again, each calculator is a little bit different. Anyway, you should be getting this to be equal to 0.469-ish, and I always start with taking that cosine first. Keep it in your calculator, though, and then you're going to multiply that by 4, and then by 7, and then by 2, and when you do that all out, you get 26.29. Okay, so let's do this quick math. Now we have x squared equaling, and let's just do that whole thing out. So we have 49 plus 16, which gives us 65, and then if we subtract 26.29 from that, we end up with 38.71, approximately. Take the square root of that, and we get x is equal to 6.2. Again, that's approximate, where x is approximately 6.2. And we're done. But if they want us to solve the rest of the triangle, again, you would use law of sines now to go from there. And remember, the downfall with using the law of sines is that there could be two possibilities, right? So you just got to do your test again if you're going to use the law of sines. but for here, they're just having you solve for x. Now, example 4, notice here on example 4, they don't give you any angles, right? So since there are no angles here, we're going to have to actually use an inverse to figure this out, which is kind of interesting. So let's see how this is set up. We're going to start it with the thing that we're looking for. So across from the angle x, we have 1.9, so this is how we're going to start our law of cosines. So it's going to be 1.9 squared is equal to the other two pieces, 1.3 squared plus 2.1 squared minus 2 times those two things, 1.3 times 2.1, and then we're going to say cosine of x. Okay, so we're looking for an angle, which means, hopefully you know what that means, but if you don't, ultimately we're going to have to use the arc cosine or cosine inverse function to figure this out. All right, so let's see how that works. So 1.9 squared is going to be 3.61 equals 1.3 squared. Just doing this out on my calculator as I go here. 1.3 squared is equal to 5.3. Okay, and then, oh, sorry, no, it's not. I don't know, my calculator, I did some quick mental math. I was like, that doesn't make sense. 1.3 times 1.3, or 1.3 squared, is actually 1.69. Okay, plus 2.1 squared, which is 4.41. And then we're going to subtract this whole piece here. So I'm just going to multiply these pieces out. So that's 2 times 1.3 times 2.1, which is equal to 5.46. Let me just double check that. So we have 2 times 1.3 times 2.1. Yes, 5.46 cosine of x. Okay, the goal here is to get x by itself, right? So let's simplify this the best we can. We can do some combination here, but be careful with the rest of it. So let's see how this works. So if I combine those two things, 1.69 plus 4.41, I get 6.1 minus 5.46 cosine of x. Now, this is all acting as one piece, so don't try to subtract 5.46 from 6.1, all right? Make sure you save that, because that's all being multiplied, all right? So you got to be really careful there. That's all attached, so don't try to combine those. Is equal to 3.61. Let's move this guy over by subtracting. So if I take 3.61 and we subtract the 6.1, we end up with a negative 2.49. Again, I just subtracted 6.1 from both sides. And that would equal negative 5.46 cosine of x. Again, I'm trying to get cosine of x by itself, so I can take the inverse, right? So let's divide both sides by negative 5.46. There's supposed to be a negative on that, but it's not letting me draw it. There we go. So if I have negative 2.49 and divided by 5.46 negative, that is equal to, it's going to be some long decimal. So we're going to get, so I'm going to move this over here. When I do that out, I get 0.45456 ... is equal to cosine of x. So to get x by itself, what I'm going to do is just keep that value in my calculator, and I'm going to hit the cosine inverse button. Sometimes you might need to store the answer on your calculator and plug it back in, depending on how yours works. But if I take the cosine inverse in degree mode of this, then my x value is going to equal 62.87. So I don't know what they're going to have you do, round it to the nearest degree or what, or to the 10th degree, but it's approximately 63 degrees if you're going to the nearest degree. And then you can use that to solve the rest of the triangle. Again, since that's rounded, everything else will be off by a tiny little bit since you rounded it. But for the purposes of this lesson, I don't mind that much on that. So that's example 4a. Now, just to save time here, I've already gone ahead and done example 6a. So if you look in your notes there, they they only give you this, and they're expecting you to draw some things out. So I drew it out here just to save time. I showed you how I went ahead and did that. And again, the angle that you know is a good place to start. So notice on 6A, since they gave me angle A, I started with A. Okay, and that's why I set the equation up the way that I did here. And then, so you can go ahead and follow my steps and my process here. By the end of it, I was solving for A, and so that's down here in the lower right. I got 4.5. Once I found that 4.5, then I used the law of sines. Okay, so after that process, like I said, I went over here and used my law of sines. Okay, and I used the sine of 26 over 4.5, which I found is equal to the sine of c over 9.3, which was given to me, okay, in the equation. And then, obviously, there's a little bit of rounding error, but that allowed me to find c. And once I know both of those, I can use the fact that it's, you know, a triangle and subtract from 180 to find my angle B, and then use law of sines to solve the rest. Now, I know that that doesn't do this whole thing justice, but just to keep this video short, I'm just going to leave the work here, which you can pause and you can look at and you can study a little bit, and then I will do some of this in class next time. And that is it. So I'm going to leave you guys with that, and we'll see you next time in class. Hopefully this gives you plenty of information to get started on lesson 8.7, Law of Cosines.